Hi, in this YouTube video, today I'm going to explain about threads. Okay, thread is a lightweight unit of execution inside a process. We all know that Java is a very good programming language, and I want to explain threading concept here. You can see thread is a lightweight unit of execution inside the process. So, without threads, how it will be like task one slash wait. I can see it has to wait. Task 2 has to wait. Task 3. There are three tasks, and each task should be completed. How it will be completed without threads? First, task 1 should be completed. Until it completes, the task 2 and task 3 both should wait. Right? Until the task 1 is completed, both task 2 and task 3 should be wait. Because as long as the task 1 is running, other tasks cannot run without threads concept. That is the problem. You take the queue, the people are standing in a queue. Only one person will be, process. One person will be will handle, will be given a support in a bank, right? So one by one. So the same way, you can see until the task one is completed, uh, task 2 and task 3 will not get executed. So now what I am doing with the help of threads, I'm going to explain with the help of threads. All three tasks are getting executed in parallel. You see, parallel execution. They won't depend upon other tasks. There is no dependency on other one task between other tasks. Threads will be spawned separately and parallelly, and their task will get executed. Okay, let's say task 1 is a big task, task 2 is a medium task, task 3 is a small task. And when all these threads are executing these three tasks, task 3 can be completed in a less time because it is a simple task. So task 2 and task 3, they will run until they complete. So the thing is, the tasks are not, they don't need to wait. Task 3 does not need to wait until the task 1, task 2 complete because they are parallelly getting executed. So here the task 3 is the simple task. It will be finished first so that the client or customer, they will see the details. They don't need to wait until the large task, complex task, big task completes. So that is the use of threading concept. I think students always feel kind of difficult when they are learning threading concept in Java. But you need to understand the theoretical concept first. What is thread and how it is happening, because there are so many things. A parallel execution, concurrency, multitasking, multiprocessing, so many keywords, buzzwords are there. You need to understand what happens with the threads. Okay. For example, where we use these threads, we use these threads in bank, web application servers, web servers. We use in banking systems. We use in Kafka consumer background jobs. So let's say you want to finish some background jobs, parallelly executing multiple background jobs at a time. Okay, these are the examples here. Okay, that is fine. Now, how we can create a thread? I'm going to explain a simple thing here. You see, I'm going to create a class myThread extends a thread class. There are two ways you can actually create a thread. One is extending a thread class. Second thing is implementing a runnable interface. There are two ways. Okay. But the better way is implementing a runnable interface. It is a little bit faster and better way of doing it when you are building enterprise applications. So when you extend a thread class, you need to override a method, run method. Okay, public void run method. Inside run method, you have to write your task details. You have to write down the task computations, related data, related code, everything you need to specify inside run method. Because when thread is invoked, the actual thing will happen from the inside run method. Okay, it will happen inside run method. So you have to consider that. My thread, my thread t equal to new of my thread. So now I'm created an object. I created an object for my thread class. And how do I invoke my thread? How do I actually invoke my thread? By invoking a start method. So when you call thread.start method, thread object.start method, it will call that run method basically. Okay, your actual code will get executed from there. So this is important point. You have to call the start method in order to invoke a run method of a thread class. Run method constitutes the actual logic, the required computation logic for a thread. Any task that you are going to specify, it has to be there. Okay, what is the next thing? Next thing is implementing runnable interface. As I told you, you can either create a thread by extending a thread class, or you can implement runnable interface. I'm going to create a class task implements runnable interface. Again, in both the cases, overriding the run method is a common thing, because inside a run method only you need to specify the logic, the computation logic, or the task details, whatever the things that you want to execute through the thread, they have to be mentioned inside a run method. So here I just specified system.out.println running a task. I did put a simple print method, sysout method. That's it here. Okay. And then what we are doing, you see here, public class test. Okay, and then static method, public static void main, and args. We are taking args as string of args, and I'm going to create a thread. I'm going to create a thread. You see, for this thread, I have to pass the object of my class. What did I have to create an object for the class which actually implemented the runnable interface. Earlier, you don't need, so you can directly create an object. You can call the start method of the thread class, custom thread class, by extending, which was created by extending a thread class. But here you see, first when your class is implemented a runnable interface, okay, you need to pass the object of that class to again as a parameter to existing thread class. This is the difference between extending thread and implementing runnable interface. When you are implementing a runnable interface, you need to pass the object of the class which implemented the runnable interface to the thread class constructor. What is thread class here? It is a built-in class. So that way a thread will be created. And again, how you are going to invoke it, it is the same. You need to call the start method. When you call the start method, it will internally invoke the run method. So you see here, these are the two ways. Thread lifecycle, generally when you create a thread, it will be new state. Okay, when you are running, it is runnable state. When you blocked it, it will be in blocked state. Let's say sometimes we suspended thread and it can be waiting state. Okay, and thread can be resumed, can be notified. These are not mentioned here, but that is also another property. Thread can be terminated. You can see here some of the methods. You see, start method starts the thread. Run method contains the main logic of the thread. Sleep method generally I want to make a thread to sleep for some time. Then I can call the sleep method. Join method, wait for the thread. There are multiple threads are executing, right? So when multiple threads are executing, uh, thread 1 and thread 2 are executing. Thread 2 has to wait until the thread 1 is complete its task. I mean, it will happen in a sequential order if you call the join method. Interrupt, it will interrupt the thread, it will provide the signal and it will interrupt it. Okay, I want to explain what is race condition, multiple threads. Let's say there is a single resource, okay, uh, and the race condition is, when a thread is writing and again another thread is reading, and before the thread is writing something, other thread is trying to read the data. So it will never happen, right? If the resource is there, then only it can be read. If you do not write any data, then it cannot be read. Sometimes it will lead to the deadlock situation. Okay. So that is called a race conditions. Generally, deadlocks, these race conditions, they are the problems generally occur when you are building threading based applications. So to avoid those problems, you need to mark any method as a synchronized, right? You need to mark any method as a synchronized. That is why you see I have an increment method, I marked it as a synchronized. If you do that, it will remove the race condition and deadlock situation. It avoids those things. Okay, so instead of manually creating threads, recently Java upgraded with the new framework approaches. You see here, executor service. Executor service, we are creating an object executors dot new fixed thread full of three threads are created, and we are simply executing service dot submit of anonymous block inside anonymous code block. We are executing that. Okay, so there are two simple two interfaces that are used in threading, runnable and callable. Basically, runnable interface, it returns no result when you do that. Callable, it returns the result. You see an example here, callable of integer task. Here functional programming again. You see it returns the result. Okay. Service dot submit of task. I'm passing the task. It will result a result. That is why I'm holding it a feature of integer result variable of type integer. So these are the concepts of threading concepts on high level. Thank you.